didn't study. They asked you to study. They just didn't tell you that. It's impossible you don't study and then do so well. Okay, so today we're going to, I'm going to finish with 4.3 and then we're going to go 4.4, okay? Time pass fast, this is week 7 now. Yeah, we are almost halfway. After this week, we're halfway through. Enjoy life every day, okay? Just life by without you notice it. So learning is the way to enjoy your life. Okay, last time we did linear independent. I think I did the point number 15, is that right? 15, yeah? I did number 15.
I think we left on at 7.
7?
Yeah, I don't think we did 15.
You mean the 4.3 number 7? Huh?
Yeah.
So I did the 4.3 number 7?
Yes.
That's all I stop? Okay. Thank you. Okay, now we're going to do 10. I changed the day of the exam because I put it, before I put it on October 27th, it cannot finish by then, so it's November something. I put it on the test number 2. Will be November the 3rd. November the 3rd, okay, a week later. Okay, this is it. Time pass fast. Okay. 4.3. Okay. I finished number 7. Okay, now the next one is number 10. Number 10. And number 10, I'm going to do part 8, okay? Okay. Then so that the vector, okay, you're given 3 vectors. V1 is equal to 1, 2, 3, 4. Okay. V2 is equal to 0, 1, 0, negative 1. V3, oh yeah, I have your quiz too, I forgot to. Oh, I miss all you guys. But you know, you saw your score, right? Yeah, I just forgot it. It's pretty good. Most of the students do well. V3 equal to 1, 3, 3. Okay. Here's the vector. They said, so that they form a linearly dependent set. They told you it's going to be dependent, okay? They want to show, we said like kind of like proof. Proof is this linearly dependent. Well, we mentioned that last time, right? We say for 3 vector, these are R4, that right? R4? Yeah? So 3 vector R4, we said no conclusion, right? Maybe dependent, maybe independent. Remember I mentioned that, right? I said if you have more vector than the dimension, that's definitely dependent, okay? If you equal, then use a determinant to do. Remember that? If it's less, now you have less, you have 3 vectors, but you have 4 dimensions. So ideally speaking, it shouldn't be linear. It shouldn't span, right? It seems like shouldn't span the set, right? We said to span the set, you must be linear dependent, isn't it? Remember that? So it seems like, because it makes sense, right? If you span, then so you can add something, and then you can make it bigger, right? So you span, right? But usually span it, you need a more vector, right? Since I used to have more than 4 vector, right? Or maybe four above, isn't it? But you have 3 vector, or when you have 3 vector, you really cannot like have a sure answer. You need to work it out. If this is a linear dependent or independent, okay? So we couldn't use a determinant to do it because you only have 3 vector, there, right? If a 4 vector, you can use determinant. Then you have to use the definition, okay? You said AV1 plus BV2 plus CV3 equals 0. And I want to see if my ABC are going to equal 0, okay? If one of the numbers not 0, then it's a linear dependent, right? If all vector equals 0, that's linear independent, that right? So our goal is that we hope that one of the number here, ABC, is not 0, okay? So what we do is we put that inside, we put the V inside, okay? So it's 1, 2, 3, 4, okay? Plus B, 0, 1, 0, negative 1, plus C, 1, 3, 3, 3. Would that equal to 0, 0, 0, 0? And then equal to 0, 0, 0, okay? And then you say, okay, A, okay, B is equal to 0 here, that right? A is there, that right? But B is equal to 0, that right? C, okay, equal to 0. So that's your first equation, isn't it? Second equation, 2A plus B plus 3C equals 0. Right? Second equation here. You guys follow me here? Okay. And then what? 3A 0 here plus 3C. Okay. Your third equation. Last one, 4A minus B plus 3C equal to what? 0. That right? Now these two equations same, isn't it? These two is the same, right? Same. Okay. Well, let's see if I can solve this one. Okay. And when I solve it, look at what happened. Right? I add them together. Look at what happened. A, look at that. 6A, right? Plus 6C equals 0. That right? Do you guys follow me here? Okay, I have a 6A plus 6C equals 0. Is that same as A plus C equals 0? Yeah? Okay. Right? Same thing. Yes?
Right.
Same thing. And then look at this A plus C equals 0 right here, right? There's another A plus C equals 0 there, right? So your answer just was A plus C equals 0. So you're going to have you need to set a variable then, set a parameter, right? So you go let C equal T, okay? Then A is equal what? Negative C is equal negative T, that right? So your ABC is just equal to what? B is a level, so B has a, set of B as a something else too. So it becomes negative T, S, and then T. Right? This marker is not very good. You guys follow me here? Okay. You have two parameters. So you have two parameters here, is that right? So that tells you you have a non-trivial solution. You have many solutions because T and S can be anything you want. Make sense? So you have a non-trivial solution, right? Not trivial. Trivial solution means they are what? Equal to 0, right? Everything equal to 0 is a trivial, right?
Right.
Non-trivial means that some number is not 0, okay? Non-trivial solution means what? Linear what? Independent, dependent. Means what? Linear what? Dependent, right? Means that you, like A, like C depend on what? A, that right? If A is equal to, A depend on C, that right? If C is equal to T, then A has to equal to something else. Equal to negative T. So A is the opposite of the C, so A depend on C, okay? So this is as a linear dependent. Then you said, why linear dependent? It means that they span it? No. Because they depend on each other, right? They depend on each other, right? There's a set, like linear dependent between the vector in the same set, okay? Like for instance, in your family, your children depend on your mom and dad, okay, like that. So you're dependent, okay? So linear dependence is about the set, okay? Span means outside. Can you span outside? Like if you marry someone else, you make your family bigger, right? So it's kind of like that. This is the best example. I think about it. Okay, this is the best example. Okay, your family used to be 4 people, mom and dad, 2 kids. When a child marry someone, move in the family, you made the family bigger, right? You have 5 people now. You spend. Do you guys follow me here? So now this one, they are really depend on each other, but that doesn't mean they're going to spend this one. It depends on can they go out to marry someone, to bring in another vector here, to make it with 4 vector. Then you have chance to spend this one. Now, your 3 vector doesn't mean you don't spend, you spend something. You could spend the subspace of the R4, but you're not going to spend R4. That makes sense? Okay. So that's what. So in case if someone said, why 3 vector can spend? Well, linear dependent. That means you can spend. It means you can make a linear combination between each other. That means you can spend. Or you're able to bring something outside to this set. We do that in 4. I don't remember, 4.7, I think. We learn to bring something outside and take away the actual one. Like that, for the vector, okay? If you give me 5 vector, I don't need 5 of them. I need to take one of them out. The best is use the minimum vector. Can spend something, okay? Make sense to you guys? Okay. So I know this is very abstract, so I want to help you guys. That's why I really try to record it so I can post it, okay? He did record it, he just forgot to give to me.
Yeah, I'll get that.
Our 2 students sent me email today. Can that student we need to remember his name, okay? Not that student, okay?
Yeah, I'll make sure to get the videos up today and tomorrow, but they'll be up. They'll be up.
Okay. I mean, this is a great class. The students do really good. I think this is a class that It's amazing because I have a few teachers talk to me about their experience in combat. They said the student was so terrible. I said, not my class, my 1C, my math 3 is pretty good. My 1C is okay. Not like that, but it's right along the same. But I think this class is exceptionally well for the students. So like better than my other class. My 1C is about normal, but they told me their students are really bad. Not means the behavior bad, their knowledge. Like they couldn't even do basic things, not even 1A, 1B, they said, oh, the test was so bad. They average is like 27%, one of the teacher told me. Yeah, average 27%. I was an average like 80 something, you guys, for this test, for this quiz. But they said, our two teachers told me, oh, the differential equation he told me it's so bad, I don't even want to grade them. He said the students do so bad. Did you guys take differential? How do you do? You got A? You take differential? Oh, so yeah, he told me that probably some students are very good, you know. But he said that's not that bad. I thought you guys, I thought you took my differential. Mm-hmm. Oh yeah, you took my differential, but I think Caesar took right now. He means that right now the teacher teaching it is very bad, your class?
No, it's not bad.
No, not bad? Okay,
No.
that's good. I know half of them are in my 1C class. I said, no, I hope they're not bad. I don't know how they do it. I mean, that they're not my 1B students, I'm not sure. Because they quite a lot of 1B material. 1C have a little bit review for different, for review for integration, so some are still okay to take. That means the Caesar quite good, because he's good in my 1C. But there's some students, they didn't take 1C yet, they go to math 2, that kind of problems. Especially if their integration is not that strong. How many students in that class? Just you?
In that one?
Uh-huh.
In total?
No, in this class. How many students in that class? Anyone in math 2 right now, taking math 2?
I think these
Or just you two? Huh?
Yeah.
You did okay?
Yeah, sorry. I mean, I'm right now.
Huh?
Yeah, I'm doing fine in the classroom.
That's good. That's good. I said, I hope my students do well. I said, because there's a little bit integration in 1C, you know, and maybe that little review for them, you know. You feel bad if your it's kind of like your children don't do well in another class. Makes you feel bad about it. If I send my student to other class, I feel bad if they don't do well in another class. It's kind of embarrassing. They say, oh no, your student don't do well, then I said, no, they all said that my student do okay. But Mr. Pacino, he doesn't know that my student from my math 3, that how my student do. He just told me, oh, Ms. Johnson, my student don't do well. But I don't know what's his standard, you know. His standard probably have 100, you know, everybody have to get 100 to do well, you know. So I don't know. But I heard that some teacher from 1A, 1B, they said terrible. They seem to terrible for the in school. And I said, oh, my math 3, I said they do really good. So hopefully you guys the same continue, okay? Okay, so the next problem is number 15. Oh, no, not number 15. Number 16, sorry, number 16. I did number 5 already, right?
Mm-hmm.
16. Okay. By using appropriate identity will require determine which of the following set of vectors are linearly dependent, okay? Let's look at part. Oh, I wrote down all the answer already, huh? You can see your answer, okay? You write down your answer so you go home and verify it, okay? And let's look at number B. X and cosine X, that's definitely independent, right? There's no way you can. Now, number 16, B. X and cosine X. And you can see that if you're gonna put the AX plus the B cosine X equals 0. The only thing can make it the same to be 0 is A is equal to 0, B is equal to 0. Is that right? Okay. Now you can also use the called the Watkins method. Okay, Watkins method can also do too. Okay, some of the problem that's hard to do it, you can use the Watkins method, but it's really up to you. But this is currently by definition, you know that there's the only chance if I want this statement to equal 0, the only chance is what? AB has to equal 0, is that right? Yeah?
Mhm.
I'm going to teach a math 2 last time, okay? Any student here need to take it? in the spring. In the spring, I'll teach it. Usually me and Mr. Bacino are taking turns. If I teach a math 2, he'll teach 1C. If I teach 1C, he'll teach math 2. Because no one else want to do it. Really, I'm not lying to you. Especially math 3, no one else want to do it. Math 3 is because it's 3 units, right? But you have to do a lot of prep. But for me, I look for enjoy my teaching. You know, I enjoy my students, so I don't look for let's calculate 3 units, lot of work. Then you don't have joy to teach anymore. You know what I mean? So that's why math 35, Taiwan teacher want. I never able to get math 35 because everybody want math 35. Because it's easy. 5 units, right? Easy teaching. So everybody, boom, math 35, that's it. And then then the next class, a lot of people fight for it, it's a 1A and 1B. 5 units, you get a better student. Okay, after that, 1C, math 2, math 3. 4 units, right? This is a 3 unit class. Absolutely no one want to teach a 3 unit. They think about, oh, that's a lot of work to do a 3 unit class. So for me, I don't look at it like that. I look at if I can do a good job on that topic or not. So you enjoy the teaching, not to think about. If you want for money, then it won't be good. Just like you look for boyfriend, girlfriend, do you calculate how much money you can get from that person first? Right? Then your relationship is not fun anymore, isn't it?
For the one getting the money.
Yeah, that's why there's one guy he kills a wife for. This is a real case it happened in Pomona. This engineer, he kills a wife because the wife just want money from him. And he worked so hard for it, right? It was on the news, 2009, you can look at it. Okay, I read it on the news. He's an electrical engineer. He worked for a company making airplane parts for Boeing. So his wife married him strictly for money, okay? He didn't know that until they married. Because when he married, he's only 43. No, 42. When he killed that guy, he was 45. When he killed his wife would marry him, and then he realized that she just want money. So he said, okay, let's divorce. His wife will move out. She won't divorce. She will not divorce. She moved out. She moved back to her mom's house, and she continued to stay for him, relationship for 9 more months. California, if you stay for how long, then you count it as you have separate. When you separate, you have to separate your money. I don't know. There's a time there I forgot. I don't know, 2 years or 1 year or what. So she make it to 2 years exactly, and that way she can get half of his money. He makes about $145,000 a year, and he has a house. He said that this is his interview, okay? He said, I made so much money, I'm not about to give half away. That a woman that who doesn't even love me, just want my money. And they will only stay together for I don't know how many months. It's not that long. So he pretended to be Santa Claus. He's a smart guy, right? He made the barn himself. And then he put a button on the collar on the Santa Claus shirt. And then he took the box, like the gift, right, to his ex-wife's house, right? And then Christmas Eve. And so when the little child come to open the door and get the box, and then he took it inside, and he went back to his car. He get a rental car. He released the button and killed, I think it was 7 people in the house. A lot of people, I don't remember. Including the wife, the ex-wife, the mother-in-law, and all those, family there, right? He knew the family's there. So that's someone just want money, and then the engineer, and he said that he said I worked really hard for my life, going to college, and then get a job, and then I don't want to give the heart away. That's what he said in the interview. I didn't like this. You can Google it. Okay? So these are for you guys okay here? You guys okay? C. Okay. D. I'm sorry, D. If I have cosine 2x, sine square x, and then cosine square x. What do you think? This one's easy now, right?
Mhm.
Right? Did you guys see that cosine 2x equal to what? Cosine square x minus a sine square x. Is that right?
Mhm.
2? Yeah?
Right.
So what do you think this should be? Linear what? If you can make a linear combination on it, that'll be what? Linear what? What is it?
Dependent.
Dependent, that right? Okay, that makes sense? Because my coefficient don't have to be 0, right?
Mhm.
I need one of these, I can make a combination of it. I don't have to be 0, I don't have to be 0 times this, 0 times that to become 0. Because if I'm going to subtract this on the other side, you can see it. To make it 0, I just need to have what? 1 here, 1 here, 1 here, right? This is equal to what? Cosine 2x, right? Cosine 2x minus cosine 2x equal to 0. Okay? That makes sense? And then for F, that's the easy one. What do you think? Linear independent or dependent? What do you think? Remember I gave you guys last week, I said if there's 0 vector inside, what is it? Linear dependent right away. How come? Because you can have any number multiplied by 0, that right? You can have any number, let's say it's A times 0 plus 0 times cosine q pi x plus 0 times what? Sine fifth 3 pi x. To make it to be 0. But although this is 2 are 0, but this is not 0. Right? Any number. Any real number. So because here one number is not 0, so therefore it's a linear one. Dependent. Okay, by the definition. So far all we did is by the definition, right? But you can also do it by what? Wronski's method, okay? I mentioned that last time. Here's a problem number 20. Okay? And they put down calculus required for that one. Okay, if I give you number 20, if they say F1 equal to ES, F2x equal to XEX, F3x equal to X squared EX. Although you can just judge by the definition, you can see if I want them add together equal to 0, the only choice is what? Equal to 0, that right? But they want to try, use a wrong method, so we're gonna try that, okay? So we have EX, X EX, X squared EX. And then we take the derivative, okay, so that's the EX. This is what? Product rule, that right? EX plus what? X
EX.
Product rule.
2x.
2x EX plus what? X squared EX. Is that right? Then you need one more. Because you get 3, then you need this 3 times. Okay, you do one more time. EX again. I think this is 2EX plus EX. Okay? And the last one is I couldn't see my own writing. This one have to do product rule twice. Because this is same as 2xEx plus x squared EX. And this is same as EX plus x EX. That right? And there's a 2 in front of it. So then becomes 2EX, okay, plus 4xEX plus x squared EX. So my line is a little bit, so let's come to here. And then you can find a determinant for it, okay? It's actually equal to 2e to the 3x. Then you don't equal to 0. Why? Because e to the any power never equals 0. Okay? And we know that e to the x graph, they never touch the x-axis, there, right? So that's why it will never equal 0. If you only have an e left, you don't have any s attached. So that's for linear independent, dependent. Now, the most important is the application of it, okay? Why do we have to learn about all this stuff? Like, why do I need to worry about linear independent, dependent, or span, and all those things? What is the purpose of all these things? Okay? So what's the purpose of it? That's the 4.4. We learn about base. That become important now, okay? So the purpose about learning all these things in linear algebra is to make coordinates. Did you guys, I don't know if you guys, any of you guys have someone that's doing art at home, okay? And you know, when you draw something, right, you can take the icon. Now my daughter, I seen that. Take the icon, and then now if she draw the pupil, she had to make the picture very big so she can draw it, right? So she can make the screen very big so she can draw just the pupil. And then she would take an icon on the corner, she download this app, some kind of app for artists. I think the Procreate, yeah. And then she would download it, then she have like a 3D icon or 2D icon, whatever you download. And he drag it to the eye, and then he started to draw that just the eye, okay? And then so every place you go, there's an icon. You can set the icon to wherever you want to draw. And then so they use the vector to make the icon. The vector become very important, okay? So that's why right now they're doing 3D drawing, okay, you can draw 3D, so they have the X, Y, Z, right? But in the future, they will want to draw like 4D, 5D, right? So they want to have this is 3 vector, okay, 3 vector, made a coordinator. Instead of the normal coordinate, we have like a huge coordinate, right? X, Y, Z, right? Expand it. No, they have little tiny coordinate. I see my daughter have it. They drag it to just the part, little tiny bit, and they just draw that part. Okay, so every part they draw, they have an icon for that. They have like a 3D coordinator. Okay, they draw it right. She will drag it to that place, and then she will sort of draw using that as an icon. Instead of icon, just for one big like SYZ with along with C, right? But there's a little coordinator made by vectors. The vector will move wherever they want to move. Then the artist can draw right there, okay? And do you guys know the software called Ulysses? I think Ulysses. Okay, so that's the one thing they do also. Okay, they for the artists, for entertainment, not just the artists, for entertainment, any games, all those stuff. And then so that this is 3 vector made by bases. Can be 2 vector, okay? Can be 2, can be 3, okay? Can be 4 or 5 or minion. But right now for what we use is a 2 or 3. 2 or 3, that's what we use right now. So they have the 5 vectors can make a coordinator for you. And this vector this is set called the base. Inside the vector called the base vector. This base vector will make a coordinator, okay? So what is the base first? Base is, I'm going to write the definition out for you. Definition. Okay. So what's the base? Maybe I use a capital here. Base is the smallest set of vectors, smallest one. Okay, means I don't want more than 92. You can follow me here? The smallest amount. Okay. The smallest set of base is the smallest set of vectors in a vector space with 2 characters. Number 1, they're really independent between each other. Okay, means that I don't need you to be around me to make me feel better. I feel better myself. Okay, I don't need to depend on you. Okay, this is very important. You need to be yourself. Okay, you need to be yourself. Very important. Number 2, spans. Spans means a vector from outside. A vector from outside. Why do I say have view? Sorry. View, I want to say view. Or I can say can. A vector from outside can make a linear combination with vectors in the base. So a vector from outside means outside the base, but inside the vector space, okay? Now, so to picture this like this, you have vector space right here, okay? And then you have a base right here. The base contains a set of vectors, like let's say V1, V2, Vn. Okay? And then these vectors are linearly independent from each other. Linearly independent. Okay? And then you have a vector from outside the base, but it's inside the vector space. Okay? And this vector will make a linear combination with that. Or you can use C or K or whatever you want to use. So that means it spans. So this means it spans. Okay? If you have these two characters, if you these two characters, then they are called the base vector. Okay? It means that they can make a coordinator. That's what it means. That makes sense, right? Because first of all, let's say I have two vectors here, okay, I and j. If I want to make an S using vector to make a coordinate system for 2 dimensions, my eyes will be right here. Okay. My j is right here. Okay. And then I can make a coordinate. I can switch the way I want it, and then on the A, I'm going to draw my eyeball, then I switch to the eyeball side, then I for the coordinator, right? So that way they won't join to a funny looking, okay? And then, so you can see this is a 2 dimension, okay? 2 dimension. I need 2 vectors. These 2 vector curve is really independent from each other, right? And then they span, how come? So they always have a span of R2, is that right? So I'm going to pick a number from R2, okay? Let's say like this, a vector from R2, okay? And you can see that R2, this is W, okay, this is W. This is equal to the 1, 0, is that right? 2 to 1, 0, plus what? 0 to what? 0, 1. So make a linear combination, is that right? So independent, now this is linear independent, okay? This is a span. That's why they can use these 2 vectors to make a coordinator for 2 dimensions. That make sense? Okay? So that's what it means, okay? Now if you can do it, then you can be a base. So these 2 vectors can use as a base, is that right? So you say, hey, I have a lot of choice too. I can have a lot of choice, can also make it be 2 and 3, right? You are right, okay? So therefore, there are many, many bases in the vector space, okay? Then they can be, maybe B prime here, right? And then B double prime and so on, right? Then who are you going to pick? That's why you pick the one that's smallest set. The smallest set. This one can be more than small, okay? That's number one. That's like more vector than supposed to be. That's number one. Number 2, they may have the base vector very complicated. It's not as good as these 2. These 2 is very nice to work on, right? Engineers, they may not want to have the complicated base. They say, oh, I don't want computer engineers, but I like the 0, 1, 1, 0. It's so easy. And then they don't want, it's easy for them to write the code, everything. They don't want to have a complicated. You can have to put like, whatever, then after you add them, you still get 2 and 3. You follow me here? So you can have more than one base in the vector space. But you only pick the one that clear what's best for you, okay? And then later on we learn about, hey, you can change them too. So for instance, sometimes they say, I'm tired of this base. I want to see if other bases can be better. You can swap them, okay? So we have changing base later on in 4.6. You guys see it now? So right now, you just learn about base first. So base basically vector, then can make a coordinator for it, okay? Can you imagine you make n dimension, n vector all perpendicular from each other? That is all linear algebra right there, okay? So right now we only, 2 and 3 are the one we see the most, okay? We know that what they use for right now. But n coordinator, n dimension coordinator, that's amazing. We don't even know what's like. What can you draw from it, right? And then that is in the future, okay? And you guys, you live a long life, okay? You get to see that, I probably won't get to see that. So you just don't know, okay? 20 years later, 30 years later, 40 years later, we don't know what life becomes, right? We just don't know. Just like one guy I was with today, I listened to YouTube, he said, when iPhone first come out, my friend buy iPhone, said, why they buy that junk? iPhone's not junk anymore, right? But when they first come out, they're not that good yet, you know that, right? Apple almost go bankrupt when they first come out. I remember the store was $17 a share. I still remember. 1996, okay? The store was $17 a share. Right now, I don't know how many times they split already, and it's still 100 something. Can you imagine if I bought the stock at $17? I won't be here. No, I teach it for fun. Okay, I don't teach it for just the money, no, any of those stuff. If I teach it for the money, then you won't enjoy your student. You will just look at them as the money. This is the money I need to grab. then your life is not, you're not going to enjoy it. Money is good, but money is not everything. Okay, remember that. Okay, money is essential to support your life, but happiness is everything. Okay, you got to be happy first. So be happy in yourself. Okay, be happy in the people around you. Okay, otherwise the life will be miserable for you. Okay, you got to enjoy the people around you. If you don't like that person, just stay away that person. Okay, you don't have to be friends with that person. You guys follow me here? You just enjoy the company around you. If you're gonna decide to stay with that people and try to enjoy that company. Any question here? You guys, Mr. Johnson, you talk too much, huh? I know. I'm also like a mother to. I know that's what Mr. Drake said. Say, yeah, like mother to your kid, to your students. I said I'm way older than them. That's why. Okay, so do you understand about base now? Okay, what base is? When I first learned this, it's like, oh, terrible, because I can't understand a thing about it. But don't worry about it, okay? Everything will come to understanding. Okay, and then the last thing is, can 0 be the base? Number 1, can you have a 0 in the base? No, because the 0 base is what? Dependent, right? Remember, you need to have a linear independent set, okay? That's number 1. Number 2, can you have a 1 vector become a base? Yes or no? What do you think? That's the computer engineer. Can you use a 1 vector to make a coordinate?
No.
No. The minimum has to be what?
2.
2. That makes sense? X and Y, right? So you need to have a minimum will be, like if I spell anything wrong, feel free to correct me. 2 vectors. You gotta have 2 vectors to make a base, okay? In your base set, you gotta have 2 vectors to have anything meaningful about this base. Okay, so 1 doesn't count. Okay. Okay, that's it. So first, 0 cannot be in the base. You need to have at least 2. Okay, can you have a many base in the vector space? Yes, you can, as many as you want. Would they have the same number? They all the same number. Okay, same number. If they're in the same vector space, there's the same number of base, but their vector is different. Okay, same number of vector in the base. Maybe I write one more thing. Same numbers of vector in different base. In the same vector space. Okay. Basis means a pole, I think. Is that right? I think BASES means more than 1 base. okay? So you can have many base inside a vector space, but they must contain the same amount of vectors in that base, okay? That makes sense? You just choose the best one for you to do, for you to use. And you can switch them if you want to, okay? You can switch them. Why do you want to switch them? Because sometimes they switch them for the purpose of easier to calculate. They do that, okay? Easy for engineer to calculate what they need to use to do the calculation. And here are some standard bases, okay? Okay, for Rn, okay, you have 1, 0, 0, n of them, okay, and then 0, 1, 0, okay, these are n, and so on, okay, and so on. Now sometimes if you see the book, this is called a horizontal writing, okay, you can write like this way also, just in case. And then your n of them, okay. It's up to you how you're gonna write it. You can write it horizontally or vertically, that's all, okay. They use the E, right? That's the same thing, okay, that's the same thing. They just said E1. I think they use it. Yeah, E1, E2, E3, like that. They can use the E1, E2, and so on. So that's for Rn. And second we see the most is for Pn. For Pn, they have a 1s x squared okay. And then for instance, P1 will be what? 1xy. P2 will be 1x squared. Okay? So matching this number, okay? You add one more number than n. You guys know that? The 1, okay? You have one more number than the n, okay? So you can see P1, you have 2 numbers. P2, you have 1, 2, 3 vectors, okay? For polynomial. And then you have a matrix. I'm going to use it just M22, okay? This is faster for me to write. Because you usually don't see same format, okay? M22 will be 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 0, 0. And 0, 0, 1, 0, and then 0, 0, 0, 1. These are 4 base vector for M22, okay? So M and M will be too much to write. Any question here? So these are 3 you've seen the most, okay? These 3 you've seen the most. And the last thing is relationship between the relationship between the span, linear, independent, and dependent, okay? Between span, there for S there. Between spans, yeah. Spans, linear, independent, dependent. So I'm gonna write out. I don't have my glasses, I didn't I forgot to bring my glasses. Access spans another vector. In the set. In the same set. If only if it is linear dependent. Okay. Okay. Relation between spans linear independent, linear dependent. Okay. They said assess, as I went through earlier, assess spans another vector in the same set if only if it is linear dependent. Remember we mentioned that I said linear independent dependent is about what? In the set, right? In yourself, okay? So that's what it means. They said you can span someone else. You can only span someone else in the same set. If you do span someone else in the same set, you are linear dependent. So for instance, if you have a vector is a twice of the other vector, like if you have a set v1, v2, okay, and for v1 is equal to 2 times of v2, oh, then you span that one, right? That makes sense? You span v1 is a twice that, so it means that v1 can span v2, right? You can span, but you only span yourself, that means nothing. You didn't span it outside. You follow me here? So you're just like inside a little family, you can do a lot of things, but you're never able to have bring more people in your family. Okay, you only just span each other there. Now then they said the access spans Rm means you span outside now. In order for you to span outside, you have to be linear independent to span outside. Because it means that you can go out or bring someone to your family. So you don't need to depend on your family. You can actually go outside to be independent and to help your family out, to expand your family. But you have to be linear independent for you to do that. If you're a linear dependent person, you can never go outside, do you? You stay home, right? You say, I need my mom and dad. You only stay out inside your house. You follow me here? But only if you're linear independent, you can go out to meet someone, say, hey, you know, then you form a relationship, then you can bring the person inside your house. Is that right? If you want to. Is that right? Then you can spend your family. Do you guys follow me here? Okay. So that's what this means, okay? That's what this means. So in order for you to go out to spend someone, you have to able to be linear independent first. Okay? That's why they have like, how come they have a linear independent set and the linear dependent earlier for the base, right? The base has to be linear independent between each other, and then you have to able to go out to meet a lot of vectors to form a linear combination, okay? Then you can span outside. That makes sense? Okay. Then we're gonna do some examples. Number 4. Okay. They show that the following polynomial form a base for P3. Well, to be form a base, you have two things, right? Linear independent between each other and linear combination with a vector outside. Well, they didn't give you a vector from outside, all right? Did they? No, they didn't. They said P3. So, and then there's a Bayes theorem. Yeah, I have a Bayes theorem here. I don't remember when the Bayes theorem was introduced. Because math, you cannot use something that hasn't been, the Bayes theorem is the next one, okay. Because they haven't been introduced yet, so I couldn't give that to you guys. That's one thing about math, so everything has to go with logic, means that you have to use the material being introduced this session to do these sessions to work. Number 4, you're given 1 plus x, okay, 1 minus x, okay, 1 minus x squared, 1 minus x cubed, all right? And they said, could this have been the base for P3? Well, P3 have how many vectors? 4 vectors, right? So they give you 4 vectors. Well, that sounds good to me, okay? So that means that there's a chance they can be what? Independent, right? And then span. Let's go back to page 126, okay? We're going to use these methods first, 126. Okay, this one. I want to take care of both, okay? I want to take care of the A linear independent, okay? So that means they depend on they're independent from each other. Another one is the E, linear combination, okay? So that means when A is equal to 0 homogeneous, okay? When they're homogeneous, they have only trivial solution. That means that everything equals 0. The coefficient all equals 0. They're right, trivial solution. A is equal to is consistent. What's consistent means? It means it's solvable. You can have a solution out of it. So in order for me to take care of both of them, now remember this is equivalent, right? I mentioned that before. Equivalent means what? One's a 2 or 2. Is that right? That's what equivalent means, okay? If I can find a determinant not equal to 0, I'm done, isn't it? If I can find this is trivial solution, then I'm done, is that right? So either one of the things you do here is a 2, then rest are all 2. You guys follow me here? That's what equivalent means. Okay, just like you and your sister, you say you talk to me same as you talk to my sister. Then just talk to one of them, is that right? That's what equivalent means, okay? So now for here 4 vector, you can pick any one of them to do. The easy one was this one. Sometimes you can pick this one, but this is sort of faster, okay? So as A is equal to 0, that means okay, they equal to 0. Would I get trivial solution? You get trivial solution, you're linear, then you're base, okay? Because that means these are 2, and then what? These also 2, okay? So if I can make linear independent from each other, linear combination with the factor from outside, then I'm okay, right? You can look at this as an outside vector. It cannot be in the base, isn't it? 0 vector cannot be in the base, right? You can view this as an outside vector. Okay, so if you can do B, your E will be also 2. If B and E is a 2, then you know that they will form a base. Okay. So what do you think? Here's an A plus a B plus C plus D equals 0. Is that right? Yes? And then what? For the x, A minus the B equals 0. Yes? You follow me here first? Okay, what about for the x squared? C
Equals 0.
negative c equals 0, that right? For right away c is equal to 0, isn't it?
Mhm.
Right? And then what about my negative d?
So
And then what? D is equal to 0. And that right? And then for C and D equal to 0, that means that these two equal to 0, that right?
Yeah.
Yes? Well, A plus B equal to 0, A minus B equal to 0, that means what?
A and B have to be
2A
0.
equal to 0, that right? Add them together, isn't it?
Mhm.
If 2A equal to 0, that means what? A is equal to 0, right? If A equal to 0, that means what?
B equals
B is equal to 0, okay? So A equal to 0, then imply B equal to 0. Then C and D is all equal to 0. So that's a trivial solution, then right? Trivial solution, okay, that means the linear independent. But then E is also true because it's an equivalent. You guys follow me here? The equivalent, right? Equivalent means that one's a true, all true, one's a false, all false. Okay? So that means what? AX equal to B has a what? Consistent. Okay, so that makes then suspense. So therefore, yes, the answer is yes. Base. Okay, form a base. So the answer is yes, form a base, okay? That makes sense to you guys? Okay, now remember, these are theorem you should always put in the 3x5 note card, okay? They carry it for you. One's a true, all true. One's false, all false, okay? Any question here? Okay, then next chart number 1, next chart number 6. Now I'm gonna go back. Now just remember this one, okay? You need to take a picture? Or you guys are only okay? No, you okay? Okay. Four, right?
Mhm.
Okay. Number 6. Okay. So that the following matrix form a base. So we do the same thing, okay? We want to see that we get any trivial solution. Okay. So A 1 1 1 1. There's a lot of writing, isn't it? B 1 negative 1 0 0. C 0 negative 1 1 0. D 1 0 0 0. What I need to become? I need to become what?
1 1 1 1.
What is it? 0, right? Because you use the AS equal to what? 0, right? The C, right? The probability C. It's the same as the probability CS is the same as the definition for linear independent dependence, isn't it? So my goal is that with my A, B, C, D has the equal to 0 for me to do that. Let's say A plus B equal to 0, okay? And the second one is the A minus B minus C equal to 0. You guys follow me here? Okay. And then the corresponding entry equal to 0. So that'll be, the last one's, third one's A, 0 plus C equals 0. That right? Yes? My last one's what? A equals 0, that's nice. Right? You guys get that? So if A equals 0, then my C equals to what? Is that right? Almost all you guys took my class before, huh? So that's why it makes it easier. So I know the background, I know the quality you guys have, so make sure you learn something. This your assets, okay? You need to know that, okay? And then what's my this is 0, this 0, my D equal to what? 0, 2, is that right? And my D equals 0, 2?
Yeah.
So what do you think about this one?
Linear independent.
Trivial solution, is that right? So that's a linear independent. Okay, that's the first quality satisfied. As a consistent. So that means what? Linear combination, right? So that's a span. So these are two yes, and then you form a base. Because this is a base character, remember? Remember the base character I wrote earlier, right? I said in order for it to be a base, you have to be what? The smallest set, but we haven't talked about that yet, okay? Right now we just talk about base first, okay? Because some of vector, you may not need it. I just need the smallest set that can span than that set. Okay? So computer engineer, when they pick the vector, they are not gonna need to, or software engineer, they don't need to take all the vector, they don't need to take the smallest, or sometimes the book called the right amount of the vector can span, okay? Any question here? Okay, then let's see point number 7. Okay, number 7B. It says, so there's not a base. This time they tell us not a base there. You can use the same way to do it, or there's a, because look at the number, that doesn't look very pretty, right? There are 164. (164), 2, 4, -1, and -1, 2, 5. Okay. Now you can do it like that way, but there's a faster way. Okay. If they give you 3 vector, right, like that, if they give you 3 vector and 3 dimension, these are 3, that right? Use the determinant, it's faster. Okay. If you can use determinant, remember determinant don't equal 0, it kills everything too, is that right? We saw that theorem 2.3.8, isn't it? When determinant don't equal 0, has all the quality there. So find a determinant, okay? Okay, it comes out equal to 0. The determinant equals 0, so that's why it's not form a base, okay? do not form a base. That make sense? It means that this is 3 vector, you cannot use it. If you're gonna design software, you just cannot use this as 3 vector. Because it do not form a base. That make sense? You will say, can I just keep using IJK? No, because then the people say that you can understand the material. That's the only thing you know how to use, right? So you are able to use the other vector as long as 3 vector are linear determinant or equal to 0. You can pick those 3, okay? Of course, later on we learn, you pick the best vector too, you know? Some vector are harder, some base are harder to use than the other base. But they give you an option, okay? They give you an option. Make sense to you guys? How you guys feel about linear algebra so far? Okay? Not that bad, right? People tell you as a boarding class, isn't it? Anyone tell you it's a boarding class? No?
Mm-hmm.
No one tell you? Good. I want you guys to be a linear independent vector. Okay? This is very important, yes. You don't want to follow people tell you what to do, then you don't have your own mind. You gotta have your own mind, okay? So, be linear independent. Okay, let's do one more. Number, coordinate vector. And this time we're looking for, remember I said that you can switch a vector, right? Yeah? A switch base, I'm sorry. Remember I said switch base can switch, right? Who can switch you? You gotta have someone can help you to switch there, right? Just like from your home to a house, you need to know how to drive, right? If you don't know how to drive, someone can drive you here, right? So you gotta have a vehicle that takes you here. So that regards to how you go. Right now you can take a Uber or all kind of way, huh? Very soon they're gonna sell driving cars, right? Just sit inside and that's it, right? So, but you have something that takes you there. So for base, in order for to switch the base, you also need something. Okay, this is something called the coordinate vector. Okay, this is the last thing I'm gonna do. So you have a vector space, right? You have vector, here they say V, and then you have V prime. Okay, two base. And I want to switch something, okay? I want to switch something, I need to call a coordinate vector, okay? Someone switch V here and someone switch V there, okay? So I need to call the coordinate vector. Okay, what is the coordinate vector? So let's say I have a vector W outside, okay, and then I have a vector here. Let's say this vector is A, B, okay, and then the coordinate vector is the linear combination. Let's not use A, B. V1, V2. Sorry, I need to use A, B later. Okay, this is a vector here. The coordinate vector is a linear combination that you form between these two. The coefficient forms makes a coordinate vector. So for instance, a coordinate vector between the vector and the B, base B, okay, is the linear combination between the vector and this one line. The linear combination W equal to A V1 plus B V2. Is that right? Linear combination, right? To form, remember form base, you are able to make a linear combination for something outside to expand yourself. The coefficient here made a coordinate vector. Okay, that made a coordinate vector. So this coordinate vector will help to smart the base. Now we need more than that, okay? We need to multiply something also. But this coordinate vector will help to smart this base. Okay, like The engineer said, oh, I don't want to use this 2 vector, and there's a 2 vector here. I said, oh, this one doesn't take me anywhere. Maybe I just wanted this one to try and see if that's gonna work better. Then you can use this vector. And then you need the coordinate vector help to do that. To go from the O base to a new base, back to O base. Sometimes you go to a new base, you say, oh no, this is worse. Let's go back to the new O base. Then you switch again. Okay, so that's what the coordinate vector for. It's a kind of like a vehicle, takes you back and forth. But it has something to go with it, okay? So I think that's all I'm gonna do. I give you that, and then Wednesday I'm going to actually do the problems, okay? Today we're just gonna do this. So that's all for today. And then Wednesday I'm gonna finish 4.4 and then 4.5. Okay, we like dimension. So Joy, you're gonna send a. So if you guys need it, then you can at least you can listen. Okay. It's just gonna ring, huh? So I'm gonna let you guys go home. Yeah, me too. I want the ring.
Real quick, 4.1, 4.2, and 4.3 will be up tonight. I'll have those.
Don't stress out about it. Okay? You can,
No worries. No
You
worries.
can give me on the weekend. I don't think they're gonna watch it tonight.